this video, we're looking at an integral with an even power of cosine in it. And when you have an even power of cosine, you're kind of stuck using these power reducing identities. So just as a quick reminder, these are really handy ones to have memorized. The one for sine squared, I may as well mention while I'm at it, just has a minus sign instead. All right, in this integral, we're using the first one. And what I'm going to do is look at the integral as cosine squared multiplied by itself, and then apply this identity to each of those cosine squareds. Well, each of those is carrying a 1/2, so I'm going to move a 1/4 out in front. Then I'm going to expand this integrand using FOIL. My first term is just 1, and then my cross terms are going to be like terms. I have a 1 cosine 2x and a cosine 2x times 1. That gives me a total of 2 cosine 2x, and that's not a hard thing to integrate. And then my last term is going to give me cosine squared 2x, and that's not simple to integrate. And in fact, I'm going to have to use my identity one more time on this in order to knock the power of cosine down to 1. So I apply this identity. I get 1/2 times 1 plus cosine of twice the angle, which is now 4x. And I'm going to clean things up just a little bit. I have a 1/2 from this term, and I'm going to combine that with the 1, giving me 3/2. Then I just have to guess the antiderivative of each piece. So for the 3/2, that's 3/2 x. For 2 cosine 2x, I've already got the differential of the inner function 2x tacked onto this. If you would rather use a formal u substitution, you would have to say let u equal 2x when you do the integral of that piece. So having the derivative of the interior function sitting right here makes it easy to see the chain rule backwards. This just comes from the sine of 2x. And it's because the derivative of sine 2x is the derivative with respect to 2x, giving me cosine 2x, multiplied by the derivative of 2x with respect to x, which is 2. So that piece is done. The next piece, in order to see the chain rule backwards, I'd really like to have a 4 sitting next to it, so that I see cosine 4x sitting right next to the derivative of 4x. And I can compensate for that by just putting a 4 in the denominator at the same time. And this gives me 1/8. And then the antiderivative of this piece is just the sine of 4x. And as usual, if you start to feel like you're getting a little too reckless with antiderivatives, you can always just check your answer by differentiating. So the derivative of sine 4x is cosine 4x multiplied by 4, giving me back this piece. The 4 cancels a 4 in this denominator, leaving me with my original expression, 1/2 cosine 4x. So I need to clean things up a little bit, and then we can't forget to add that plus c at the very end. So I have 3/8 x plus 1/4 sine 2x plus 1/32 sine 4x plus c. And we're done with that one. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.